Hello everyone, welcome back. So in this video, we are going to discover another formula, which is distance formula. In the previous video, we talked about the slope formula, and we know we can use slope formula to prove if two lines are parallel. And in this one, we are going to discover another feature for proving. So in this one, we are going to use distance formula. The very first thing, let's quickly review. You probably see this formula before in Algebra 1, but if you haven't, which is perfectly fine. So the distance formula, it looked like a long one, right? Compared to the midpoint formula, it's like everything here. But if you really look closely, you will see when I have two points, and when we read the coordinates, we find the difference between x and then squared it. We find the difference of y and then we squared it. The final answer need to square root of this. So it's actually coming from this. So we find the difference of x. This is the difference of x. We use delta x to represent. And then we find the difference of y. This is a difference of y. And you're actually looking at a right triangle. And this D is actually representing the hypotenuse of this right triangle. So now you probably know this is actually coming from Pythagorean's theorem. So we actually use originally Pythagorean's theorem to find the distance of the two sides and then square both of them. Finally, we need to square root because originally it's a squared plus b squared equal to c squared. So basically to find c, we just need to square the sum of these two parts. So that's actually how distance formula coming from. It's nothing new because we all know Pythagorean's theorem. We just you apply this idea into a random situation when we deal with a question like finding the distance between the 2 points. So you may wonder, like what we mentioned before, we use a slope formula to prove two lines are parallel. Then what do we use distance formula for? So distance formula, as you can see, I can find the length of the segment, right? So if I give you a random two line segments, so if I can find the distance of both line segments, I can compare if they have the same length. Then if they have the same length, that means they are congruent. So that's how we use distance formula. So when the two line segments have the same distance, meaning they have the same length, which means they are congruent. So that's the idea of using distance formula. So distance formula can help us to find the length of the segment, and when we compare it, same length, of course, they are congruent. That's actually a very original definition of the congruent. Okay, so very similar to the slope formula, we are going to look at one question, and we are going to use this question first practicing how to use distance formula, and then we are going to use this idea to prove if two line segments are congruent. So as you can see, this is actually very similar to the one we just did before. The graph is same, but this time the question are different. This time we are looking at this two line segment, but we are going to prove if they are congruent. So as we mentioned, if you wanted to prove they are congruent, we need to find the length of the two segments. So that's why we are going to use distance formula to find how long for each line segment is. Again, most cases we just use D to represent the line segment. You can write down DAB, this is actually just distance, or you can just write down the distance of AB, whatever the way you like to represent your calculation, that's also fine. So I just use this one to represent, or if you prefer to use, for example, the one I use here is lowercase d, so we can also use lowercase d here. So DAB, meaning we are going to look for the distance of AB. Again, when we use this, very important, we need to use we need to find the coordinates. So this one is 2, 6, as we did before. This one is -5, 2, 5, 2, -2, -2. Double check the sign, double check the values here. Once you make a mistake here, it's going to be very hard to have, right answer here. So now let's write down the distance formula we are going to use. Remember, distance formula, we find the difference between the x squared it. We find the difference between y squared it. Okay? So we are going to find the difference between the x. Doesn't matter which one you put in the front, but make sure you follow the order of operations. So I put this one 2 minus -5. Whenever I say negative, the minus, I always prefer to put a parenthesis to remind me is minus minus. Squared it, that's a x, the difference between x, and then difference between y. So we can just do the calculation, which is the first one is 2 minus -7, 7 squared 49. 6 minus 2, 4, 4, 4, 16. If you prefer to use calculator, which is also fine, but please make sure you put everything accurately. Do not miss parentheses, do not miss a square part, this kind of thing. So do not miss that. Then we just put the value here. So 9 plus 6, 5. 65. So this is the square root of 65. Let's leave it here, and then let's see what happened to CD. CD here is going to be a square root. Again, we find the difference between x, 5 minus -2 square, and then 2 minus -2 square, parenthesis. So if you check this number, you probably already figure out 5 minus -2, 7. 7 squared, 49. 2 minus -4. -2 is going to be 4. 4 squared, 16. By the way, when you type in the calculator, sometimes people very easy to make mistake like -2 square, you type in the calculator as -2 square, so you get -4, which is actually wrong. Because -2 square is -2 times -2 should be 4. So please make sure do not make this kind of mistakes, okay? So let's erase this part. I just, remember this kind of mistake I always see every year. So please make sure you do not make mistakes. So we have exactly same thing, square root of 65. So we don't need to actually simplify this number. As long as I see they have exactly same number, I know they are equivalent. So they are same. So now, again, very similar to the, the one we practiced before. Even you finish calculation, you need to write down the conclusion to explain what your calculation means in this situation. So that means we actually come to the conclusion. AB is congruent. Sorry for my writing pad is not working well right now. So AB is congruent to CD or DC, the order for the line segment doesn't matter because they have the same distance. So don't be, again, this is like how we communicate. When you write down your essay, you want to make sure this is actually a complete one. When people read your essay, they understand what you mean, they understand your opinion. Everything is clearly stated. So same thing here. We use a final sentence to indicate what does that mean when I do this calculation. This calculation will lead to the final conclusion. They are congruent. So that's one thing. Do not forget the final proof. Even this is like writing, but don't be lazy for missing this part, okay? So this seems like a little bit tedious because you do a lot of calculation, but once you get used to the idea, all we need to do plug in the value and we just do show the final calculation and similar to a parallel. So finally, I just want to quickly summarize what can we do? What are we going to do when we use coordinate geometry to prove? The very first thing is always based on the question or information, because later on we are going to prove, probably I gave you a picture and I give you a quadrilateral to prove the parallelogram. So information can be different, but we always need to choose a formula. Are we going to use distance? Are we going to use slope? Or are we going to use both formulas to serve the different purpose? And then we always need to read the coordinates because that's a very most important part in coordinate geometry. We read the coordinates from the diagram, and then once we decide the formula to use, we plug in the value into the formula. Please make sure the order or the value to make everything correctly in this step. Finally, final two steps, we need to show the calculation. Once we finish the calculation, do not forget we need to write down a final sentence as our conclusion to explain what does that mean. Do they have same distance? Then what does that mean when they have same distance? Do they have the same slope? What does that mean in the same slope? So sometimes you might see, it's provable, like they are congruent because they have the same distance. But if you your calculation gives you an idea is, hey, they don't have same distance. Your conclusion can be they are not congruent because they do not have same distance. So that's exactly why we need to write down the conclusion to confirm what is your discovery. Okay, everyone, thank you so much. I know there's a lot to digest today because we do so many calculations and we do so many things at the same time. But definitely pace yourself. Choose a time you really want to dig into these concepts and sit down, watch these videos, check these examples. You can even just pause the video to do some calculation on your own to see if you can get the same conclusion as I did. But thank you so much to study this topic with me, and thank you so much for watching these videos. Take care, everyone. See you soon.